Hey, Algebra 2, we moved on to Lesson 6.2 today, and we are working with properties of radicals. Hopefully you know that a radical is a square root. Our essential question is, can you simplify radical expressions? And we're going to look at a couple properties before we do this. So, product and quotient properties tell us that when I multiply the nth root of a times b, I can split that up. Nth root of a times the nth root of b. In the same sort, when I divide the nth root of a divided by b, I can split that up. The nth root of a divided by the nth root of b. So let's see what they're talking about here. Remember yesterday we talked about a couple things that you need to know. So for example, you need to know all your squares and cubes. And after that I said, hey, be really familiar that 2 to the 4th power is 16, 2 to the 5th power is 32, and 2 to the 10th power is 1024. I also told you that 3 to the 4th power is 81, and 3 to the 5th power is 243. And these are just good to know because of questions like we're coming up with. The 5th root of 64 has the 5th root of 32, which is a perfect root, times the 5th root of 2. So since the 5th root of 32 is a perfect root, I can cross this out and say that this is just 2, because I know that 2 to the 5th power is 32, times the 5th root of 2. On the same note, if I look over here, now I have a square root. And you probably can see that the perfect square that can come out of 18 would be 9 times 2. Notice I'm writing those both in radicals. The perfect square that can come out of m to the 3rd is m squared times m. And again, we're going to cancel out what we can cancel out. I know that the perfect square of 9 is 3, and the perfect square of m squared is m. So I'm going to take out what I can take out and leave in what I can leave in. So I have 3m times the square root of 2m. Alrighty, this one gets a little fun. We're dividing. I can split this up to be the cubed root of 81 over the cube root of 8. And you guys are already saying, hey, I know the cube root of 8. The cube root of 8 is 2. So yes, always simplify that. But 81 we have to break up. So is there a perfect cube in 81? Yeah, the perfect cube is 27, and I know that 27 times 3 gives me 81. Well, the cube root of 27 is 3, so my final answer is 3 times the cube root of 3, all divided by 2. A lot of 3's in that one. All right, this one I would encourage you to star, circle, highlight, because this one you're going to see and see and see again, and soon you'll be doing these in your noggin. You won't even know that you know how to do these. The problem with this one is if I have the cube root of 5 over the cube root of 4, I can't answer with a radical in the denominator. So I have to do what we call rationalizing the denominator. Rationalize the denominator. So, in order to rationalize the denominator, I can multiply anything through by 1. Well, I want to make this 4 a perfect cube, and I know if I multiply it by the cube root of 2, I get the cube root of 8, which is a perfect cube. So, I can multiply anything through by 1 and not change its value. So what I do to the top, I have to do to the bottom. The 3rd root of 5 times the 3rd root of 2 is the 3rd root of 10. And the 3rd root of 4 times the 3rd root of 2 is the 3rd root of 8, which you guys just told me was 2. Now, beware, because this 10 is inside of a radical and the 2 is not, they cannot be reduced. All right, a couple more things that we want to look at. I just want you guys to see something like this. There are a couple ways to do this. You can just multiply the numbers and multiply the radicals and reduce from there. But I like to reduce because I don't want to deal with a bunch of radicals. So I know 4 times 6 is going to give me a perfect square. I also know that 4 times 2 is going to give me the perfect square. When I take 4 out, I get 2. So now I'm just going to multiply my numbers. So I have 10 root 6. And I'm going to multiply my numbers again, and I have 6 root 2. But as you can see, I can continue. So let's continue to multiply. 10 times 6 is 60. Root 6 and root 2 is root 12. And you're thinking, wait, there's another perfect square in 12. Yes, there is. I can break this down to 4 and 3. The perfect square of 4 is 2. It looks like our final answer is 120 times the square root of 3.